Steel and Wheels. On this episode, I'm just going to show you some of the engineering side of things and what I've done to prepare to do this job and whatnot. What is the job, you ask? We are going to build the elevator. Some of you might call it a lift, some of you might call it a ground to the fucking roof, I don't know. That's what we're doing, the elevator. There's been a lot of work back and forth between me and my engineer. Great mate, big shout out to Dino for helping me out there. Yeah, it's been a lot of work going into it, so I'll give you a rundown of what we're doing, where it's going, some of the materials we've chosen, why we've chosen that to go that direction, the winch, how many kilos that is and why we can go that many kilos and how that operates and whatnot. And then in the next episode I'll try and get into a fair amount of detail as we build it to the next level to show you how it's built. Alright, so as a start, that's where it's going to go. In that hole. So when my old boy built the mezzanine floor, we left this hole out just to do this. So that's where it's going to go. We're going to cut that beam there out because we are going to try and build a lift on the floor there. Basically because that's to the roof. From memory, I think it's 4,700 or 4,800. Might be 4,800 to the roof there, and then to the roof there is like 50. Sorry, no, that's 51 and that's 54. But we're now going to build it so it's lower than that piece right there, so that we can actually sort of like scoop it up and in. Bit of a scoop up and in job. So now she's 47, 90 or something, and 51 underneath that beam. That beam will get taken out, we'll move it to this side. So basically we'll just do a flip flop and then attach back to this piece here, out here. That piece will get removed. I'm not sure if I'm gonna put it back. So yeah, that's basically where it's gonna go, how that's gonna work. So we'll just get it over to here somehow and just straight in the hole. That's the plan. I bet you it doesn't work out like that, but that's the plan. So this is material. This is all 50 by 53 mil. There's a few lengths there because half of it is for a different project. The 75 by 50. Now that's because the uprights have to be 75 by 50. So up and downs. And then also the top piece that runs this way has to be 75 by 50. The one that goes that way will only be 50 by 50, but this one has to be 75 by 50. And then also where my winch mounts on top of it all has to be 75 by 50 with a 6mm sheet on top to cradle the winch. So that should be good, that should be okay. I did intend on trying to get a cold saw. For you who don't know, the cold saw runs like I don't think it's a carbon blade, but or a tungsten blade, but it's not like a grinding blade itself, it's actually a cutting blade. So it looks very similar to your tungsten carbide cutting blades or whatever they're actually called, but it looks very similar to that, big teethy kind of thing, but yeah, my budget just doesn't allow for that, so we're gonna use a drop saw, which will liven things up a little bit because angles are critical. Just for any peace of mind for you guys to understand now, for every degree that I'm out once I weld this, from bottom to top could be upwards of 80 mil out of square. So it's really critical that I spend a lot of time making sure it is square to the degree. The squarer it is, the better we're gonna be. Alright, so this is a little winch, 800 kilo winch. To get 800 kilos, I don't know if you can actually see it on here. So if you get 400, it's just a single strand. If you get the 800, you've got to double it back over. So basically like that. Reattached it there. So now here we'll just run on this hook here. That'll basically go in there. Another run on that. These are the traditional mounting points, but we're doing away with that. We are going to mount it directly off of its 4 mounting points underneath here. So I'm just going to put like the piece of 6mm flat on the top, and then this will bolt to that. So that should be fine. We have to extend this extension lead, so I'll probably run it all the way back, disconnect it, this one right here. I'll probably pull this motor off, like the electrical box off the motor, undo all this, undo it out of there. I bought just a cheap extension lead to come in here and annihilate all that. So that should be good, should be easy enough. We got extension leads because the nearest power for me is over there beside the fridge. That's the nearest power, so it'll have to go up that wall to there, across and then out to roughly there, somewhere there. So yeah, that's pretty much the thing. The only thing we've got to get things up there at the moment is this. Doesn't cut it, trust me. It's just not as good as it could be. Alright, what I'm going to do now is we'll go to the computer and I'll just do voiceovers, actually show you. And then my engineer's done some voiceover for you as well. We'll show you how the engineers work their stuff out. So there's going to be drawings where you basically see maybe half of it and then the whole thing, and then there's points of where it shows you the stress and how they show you the stress. So there's one drawing there that's more like a video. It's a great video. It shows you exactly where the stress is allowed, and it's also overbearing of what we want in weight wise, so that's great. So this project will come out, the whole thing's rated to 1,000 kilos, but the lift, the winch itself is only 800 kilos. The price difference is phenomenal, and I don't feel like I want anything that heavy up there anyway. So the frame and that are rated to 1,000 kilos, the winch 800 kilos, the internal box carrier, I'm not sure what you want to call that bit, but we'll call it the carrier bit, cage even. It weighs about the 220 mark, I think, kilos. So she's a little bit of a heavy son of a bitch, considering the outside massive frame is like only just over 100 kilos or something. Yeah, but we'll get into that. We'll go up there and we'll get on the computer and I'll do some types, and we'll get it all up and show you what the ins and outs to doing that are. Alright, thank you guys. If you want to see the build, make sure you like, share, subscribe. Hit the little bell. Normally it's over, probably down there somewhere, to be honest. Underneath your video, there'll be a bell, or if you're watching full screen, it may be up in that corner. Yeah, I'm not too sure, but I think it's either there or there. If you go one of those sides, I think you'll find it. Let your mates know, share the channel. If we start getting more subs, I'll start building bigger and better stuff. Yeah, alright, cheers guys. I'll see you on the real episode. Alright guys, so this was basically the first image I sent Dino. We did have a couple like 2D style drawings that he didn't like and wasn't very happy with, so he asked me to do it in 3D, so I had a crack at that freehand. As you can see, it doesn't look quite right, but he got the gist a lot better with a 3D drawing. The measurements changed as we discussed how it was going to be built, how it was going to fit, placement, yada yada yada. The measurements have changed again since this drawing, but this basically gives you an idea of what's going on. Basically, the red bit at the top is the winch, the green is where the winch will connect, the black uprights are of course the uprights, the base and the top, and then all the orange is just the lengths that we thought it was going to be, and it didn't end up being them, but that's the rough drawing of where it all started, and we went from there. Now, I thought this one was pretty funny, so I thought I'd just add it in for you guys. This was Luffy's interpretation of how an engineer would probably design this in his mind. Normally, when you meet a lot of engineers, they love to like heavily over-engineer everything. So basically, the middle section is all the uprights, and then you got the floor and the top, and then just gussets and braces just coming out from every direction possible. I thought I'd show you that because I thought you might think it's a bit funny, as we did. So I hope you enjoyed that, guys. Alright, guys, so this is basically some drawings of the lift in its 3D form. The blue is gussets, green is bar work. The middle section is where the lift will be mounted. The green is also 75 by 50. The purple is two pieces of 75 by 50. The red is 50 by 50. And the blue is 50 by 50 angle. So these are all just different views of the frame itself and how the frame is designed by the engineer Dino. So as you can see, the bottom is all 50 by 50, basically because it takes no structural support. It's basically just a resting point for everything. This is just another view again from a different angle of it. So everything's got angles to gussets. This is a cut apart, so you can sort of see it in different sections and help you understand it from a different point of view or how it may work. That's basically how they're going to sit, so they'll overlap. One side will overlap and then one side won't. Just another cutaway. That's where it's all going to meet for the winch, but we've changed that design slightly. As you can see in this image, we've reshaped it so that it's two pieces of 75, not one. This is just a full image of what the actual lift is going to look like in its complete form. It has had a few minor adjustments since this image was drawn, but that's basically what she's going to look like when she's finished. Alright guys, so that's an overall view of the build, but looking straight down on it. Gives you some dimensions and roughly what it's going to shape out. That's the three-dimensional sort of drawing that I can build it off of with everything that's going in there. This is for where the winch is going to mount and how that's gonna come about. This image will help you see it a little bit better. So the winch is in the middle, two pieces RHS down each side, flat plate across the top, and some bolts, hook it up, no problem. The red piece of RHS on the right hand side is essentially the roof or the top of the lift and where the whole winch cradle bit will mount on top of.
So that's in line form. So you can see there's the two RHSs side by side, just there. I've just put a join between them representing the lifting lug. And then your braces, your angle braces, and then your 50 by 50 uprights, 50 by 50 there, and all those are 50 by 50 as well. So the red is 50 by 50 there, and then the green is 75 by 50, and that's the double 75 by 50. Now they can be spaced apart, so we can talk about how we can reduce your head height, because you've got a fair amount of gap between your hook and your hoist and then your top back. This is it rendering from the underside, so it's looking underneath. So yeah, you have the double cross like that, and 2.5mm or 3mm plate, and then your uprights, and then your waist rail, and more uprights. And this is the results view and displacement. The four people standing with both feet on the ground, and that blue represents 6mm displacement, but the corners are basically 2.5mm, so it's actually 3.5mm total from there to there, so you will feel about 3. And this is four guys all standing on 1 foot, and you can see the deflection is basically the same, 6mm. So it's a 4mm deflection, so it changes from 3mm to 4mm, from 1 foot to 2 foot, so you won't notice the difference. So yeah, it's really well balanced. Total displacement 6mm, so that's nothing. And this is like that instant, if you jerk the hoist, total deflection is 8mm, so it means that the distance from there to there, or your foot is 8mm, but from there to there is 3mm, which is exactly what you want. So that's all. Everyone's standing on 1 foot and then bang on the hoist.
Hey guys, and thanks for watching. Tune in on the next episode as we start the build, and we'll see how we go. Hopefully it all fits in place and nothing goes catastrophically wrong. I hope to see you there, guys. Bye.